We have with us Alessandro, who is the chief scientist at GraphAware. I imagine you could tell from the name of the company, we got more graphs, which is great because they're definitely being underutilized. And we just had an awesome talk on them. So I'm excited to see kind of digging into the topics that we just learned from Amy and David, but like into a very specific use case, which I think people love. I think the ordering of that is awesome. So Alessandro, thanks for coming on. Maybe tell us a little bit
Thank you.
about your background, how you got interested in graph work, and like your how you got to this point.
Well, actually, I started working with graphs since I would say 15 years, just as a side project, and then I joined GraphAware, and I started consulting several big companies, promoting graphs for whatever recommendation for natural language processing, for many other topics. So much that I wrote the first book that is called Graph-Powered Machine Learning. Actually, that received quite a lot of interest from people who wanted to join the, let's say, the world of graphs and machine learning. And now the next book will be actually on knowledge graphs and LLMs in action. That is already available in MIP, and it should be released in the final version quite soon, I hope. Yeah, and that's why I'm here, to present how we can combine these nice technologies for specific use cases related to our current focus, that is law enforcement and police, let's say, departments.
That's awesome. I mean, one of the very cool things about graphs with LLMs specifically, I mean, it applies with a couple of other domains too, but graph machine learning and graph work, even before machine learning, just like graph systems, are so much older than LLMs. Like LLMs just got here, and so a lot of people are like, oh, this just feels like hype on top of hype. But like graphs are a really rich research area. Like it didn't just become popular because of LLMs. Like people have been digging into this for 15, 20, 25 years. And so the fact that they apply on top of LLMs is great, but it's even more powerful because they're coming with all of this research and all of these skill sets and this knowledge that just doesn't exist yet in the LLM world. But so we're bringing all this robustness, which I think is a reason why it was able to come on really quickly and then really explode, just because there's so much that's there as opposed to hype.
Definitely, and the combination is able to disrupt in several fields, in several domains, actually.
Yeah. Okay. I think this is perfect timing to jump in. I don't see your screen yet, but if you share your screen, we'll bring it on.
Let me
and
try. Let's see if it is. Is it no?
Yep, there it is. Maybe just go into presentation mode. It'll be a little bit bigger.
Let me see. Can you see it bigger?
Yeah, this is perfect. Okay, whenever you're ready.
Cool. So, good morning, afternoon, or evening, depending on where we are sitting today. So you joined this conference to learn how AI technologies can support different real scenarios in a production environment. So today you will discover how knowledge graphs and LLMs are helping law enforcement agencies around the world to disrupt criminal networks. Whether it is fighting drug trafficking or countering terrorism or finding missing children or addressing any other pressing security challenge, you will see how these technologies are literally revolutionizing law enforcement intelligence practice. And I'll walk you through the journey our customers have taken in adopting these transformative technologies. But before doing that, let me quickly introduce GraphAware, the company I work for, because for the last 8 years, we have been empowering law enforcement agencies around the world to solve crimes faster and more efficiently. And our flagship product called Yum is a mission-critical analytics platform entirely built on top of knowledge graphs and recently using LLMs to empower interesting features. So some of the snapshots you will see today actually are taken from Yum. Nevertheless, what I'm going to present to you today is still valid with or without Yum. So I'd like to start this presentation from the end, from the impact that these technologies combined can have on people's life. This is Sarah, and while her name and her picture are generated, her story is unfortunately real, because she represents countless minors that have been saved from harm because a knowledge graph system was able to capture a specific pattern on time. In this case, a sexual offender that was found close to an unrelated minor in proximity of a restricted area like a school. Before the introduction of such a system, such a knowledge graph, this type of patterns could take up to 11 months to surface, with the consequences that you can easily imagine. After the introduction of this system, instead, these type of patterns can generate alert almost in real time. So Sarah's case is one example, just one example of the issues that law enforcement organizations and police forces around the world are facing every day. But let's go a bit in detail. These are a few sentences that I taken from a few police journals, but they resonate very well with what we hear again and again while speaking with our customers, prospect, or industry peers. These challenges related to data management, incomplete or insufficient collecting capabilities, or legacy software are common across all police forces, all law enforcement agencies around the globe. And they have a lot of reasons, but let's see what they are. Starting from the most common one, the data pain, because nowadays analysts are dealing with an enormous amount of data as never before. They often struggle to find the right information quickly enough to make a difference, to save SAR, for example. Moreover, this data is disconnected, distributed and scattered across multiple data sources, each with a different schema, different access pattern, different access right. Moreover, this data is also often unstructured, and I'm referring not only to text, but also to video, audio, images, etc. And this data, unfortunately, often is incomplete and even contradictory sometimes, making the analyst work even harder. That's why the data pains are directly connected with the analyst pains, because let's say the work of the analyst is time consuming, because they spend an enormous amount of time searching across these multiple data sources. Often they are coming through our spreadsheet, databases, intelligence reports, for getting whatever information, vehicle registration, personal details, etc., trying to stitch together a comprehensive narrative. Their work is not just time consuming, it's also repetitive and error-prone, because they accomplish the same tasks again and again. And these are tasks that could be fully automated if they had a proper data management platform. Moreover, their work is also complex, because they not only have to search through multiple sources, but they have also to cross-reference the data that they will get, and sometimes this happens without any ID that could help them to connect the data, and they perform this often manually with an enormous time required for doing that. And then we have the manager's pain, because law enforcement managers all around the world are facing a significant resource constraints. They don't have enough staff to handle the workload that they have to. And I'm not speaking just about the analyst, I'm speaking also about the police officers in the street. So key for them is efficiency. They should remove any source of inefficiency on the other side. And moreover, they lack of a comprehensive visibility over the data, which makes this process of allocating properly resources even more complicated. Imagine that you have to deal with a citywide operation with disjoint information, or with a limited visibility on the data. That would be very, very hard. But I will say that luckily not all is lost, because the fact that it was working like this doesn't mean that it must continue like this. And we are all here because we would like to improve the practice, So actually, there are different ways in which we can improve this way. And I'm sure that through this conference, but also in other conferences, even specialized in law enforcement, you have heard about different tools offering to improve the analyst efficiency. And I'm sure that many of these tools actually offer a graph or knowledge graphs as a powerful visualization tool. But this is not enough, because while these are valid solutions, what I'm speaking about is something that is deeper than that, that goes beyond using graphs as a visualization tool. In the mental shift I'm speaking about, you should consider knowledge graphs as foundational assets, because they restructure the way in which the data is stored, is aggregated, is merged, is visualized, and also analyzed. By embracing this knowledge graph paradigm, these agencies can offer to the analyst a way more powerful tool, improving their performance, and also offering the opportunity to extract important insights that could be useful for analysts as well as for law enforcement managers. But let's start our journey by introducing a bit better the knowledge graphs, even though you heard a lot about that. But let me take it from a different perspective. Because knowledge graph is not just a data structure, it's a model paradigm, where you can store the real world entities and their relationships in a natural way, in a very simple way. Let's see how it works in the specificity of the law enforcement space. Imagine that, in this case, you will have data about people. Of course, there could be suspects, witnesses, victims, etc. Then you have information about crimes, vehicles, different locations, and perhaps specific type of data like drugs, guns, weapons, and so on. In the classical configuration, I would say, all these the data actually is scattered across multiple data sources, with the little or no connection between these. Once you introduce a knowledge graph system instead, all these information will be well organized as nodes and relationships, and they will be naturally connected. Coming back to our example, we will have people. These people will be connected with crimes in different shapes because they are, potential offenders or they are victims, etc. These crimes can be connected with locations, crime scenes, meeting points, etc. These locations can be easily connected with vehicles that have been spotted in the area by traffic cameras in a time frame close to the crime scene, to the crime. And these vehicles in turn can be connected with other people of interest. So in this way, we've seen how we can easily connect, even though they are far away, different type of information. And we can spot relevant patterns even where they are far, and this would be literally impossible in the classical system when the analysts have to do this manually. So supposing that, I think that you guess it already, but let me reinforce again why the knowledge graphs is so powerful in this context. First of all, for the flexibility of the data model, because in this way it is very easy to merge and integrate different data sources, regardless of the original data structure, the original data pattern, etc. Moreover, in a knowledge graph, or let's say a knowledge graph offers powerful navigation patterns, because every single node and every single relationship is an entry point of these of your analysis, and then the analysts actually can navigate through the connections and can discover easily patterns, because they will emerge during the investigation process. Moreover, having this well-organized knowledge, where all these nodes and relationships allow you to organize your data, your information, actually you can apply easily machine learning algorithms, so graph data science algorithm, and extract relevant information, relevant insights that could be useful, again, not only for the analyst, but also for managers, dealing with a wider set of information. So supposing that I did a good job so far, and I convinced you that knowledge graph can be available support in the law enforcement space. You might be wondering, how comes that not all the law enforcement agencies around the world are using it? Well, there are different reasons for that. First of all, the transition, is not simple because joining the knowledge graph paradigm is complex, because they are powerful, but they require to change the way in which these organizations are dealing with the data, are storing them, are granting access to this data, etc. Moreover, using these tools and these technologies properly, without guidance or without the proper tools, etc., could be overwhelming. And this is another major blocker. And then there are cost considerations. And I'm not speaking just about the price that you have to pay for the licenses, but also in terms of effort that these organizations have to put on the onboarding, on the adoption curve. That's why I like to present this picture that really represent these poor analysts that are so busy in doing their job in the way in which I described it before, that have literally no time for embracing a new technology, because this could mean that they will not save Sarah tomorrow because they are so busy in cross-referencing manually all these data. That's why after dealing with this problem for 8 years, we came out with a proven process made by 3 steps that is iterative. And let's say that the greatest advantage is to go through this process with a meaningful but a small goal at the beginning to shorten the time to value, and then reiterate taking a different goal and then going through the process again and again. And this actually showed how we can make the adoption curve way simpler, and at the same time we can provide valuable outcomes at each iteration. Before going in detail, I'd like to spend a few moments reflecting on what is the role of generative AI in general and LLMs in particular in this process. Because even though we have done this for the last 8 years, actually in the few last years, actually something changed completely. Because in particular, LLMs change the way in which we accomplish several of the tasks inside these 3 steps that I summarized in this slide, and then we will see later. Because first of all, of course, they helped us to dealing with unstructured data that was super complicated before. With the introduction of LLM, this step was oversimplified for sure. Moreover, it helped us to widen the target user base, because via the implementation of a natural language interface, we can go out of the analyst desk and embrace the police officers in the street. And we will see even here a few examples later. Moreover, since you have this data and you would like to analyze all this data with machine learning, sometimes all these insights could be overwhelming, because you can get so many insights that it will be difficult to go through them properly. So even in this case, LLMs helps us to literally summarize this information to provide an intelligible format of these data. So let's start with the first step that, as you can imagine, is literally the process of taking all these data sources and condense them in this single view of intelligence. This step is made by multiple subtasks, where the first one is clearly the identification of a clear goal. As I said at the beginning, this is an iterative process, so you don't need to deal with all the goals. But what we suggest generally is to take as a first goal something that is meaningful, but at the same time handful. Something that you can manage in a short amount of time to shorten the time to value and prove the value of the solution. At that point, once the goal is clear, you should identify what are the different data sources or the portion of data sources that you need to accomplish this goal. At that point, you have all you need to craft a first knowledge graph. Even here, it's not the final version, because the knowledge graph will evolve constantly over time, but it serves the purposes actually. At this point, you can perform the ingestion, mapping the original data structure against the created a knowledge graph model. And after the ingestion, of course, you have to perform some post-processing that, apart from the classical data cleaning, you can also perform entity resolution, which means that you can literally connect the 2 entities representing the same real-world entity so that you can get more connections in the future. I like to say that in this phase, you can be very, very creative. Moreover, in this phase is also where generative AI and these new technologies can help a lot. Here, I have an example of what we have done with the images. We use of course, machine learning to recognize faces, then to extract fingerprints, and then to clusterize these fingerprints so that each cluster can represent a specific person. At that point, we can literally create connections between people because they appeared in the same picture, and then we can run, of course, community detection algorithms and so on and so forth on this graph, extracting very important insights. As I anticipated you, LLMs here had a very critical role, because before the introduction of LLMs, actually we had to fine-tune NLP models. That was a super tedious task because you had to go through these annotations that will take a long time, and then the results were generally not as good as they should be. With LLMs, actually, even taking the publicly available models, you can get very good results in entity and relationship extraction from text, and this can be naturally stored in the graph. So we are using LLMs for the knowledge graph building phase with the greatest success compared with before. In the second step, what happens is that we literally transition from the classical search-based approach to a more exploration-based approach, because literally what these analysts were doing before, it was just to search and then they manually compared the results, But here, you can still start with the search, or the analyst can start with the search, but then they can literally navigate through the graph. So it's important that the solution that we offer provides the capability to navigate through this data in a powerful way. Moreover, even though search is a powerful starting point, actually you should use graph patterns, like in the Sarah's case, to describe what you like to get, and the system should provide something that will simplify this work. At the same time, as in any other system, you should have some stored procedure that will aggregate this data properly, these queries properly, and then you can run it multiple times. And of course, you need to offer, due to the specificity of the domain, some temporal graph navigation and some spatial visualization. Here, a few examples from Hume, where we can see on the bottom left an example of the graph pattern, and we have an example of the graph navigation, and of course an example of a map that, as I said, is critical in this scenario. Again, LLMs, great advantage even here, because we are experimenting how we can use LLMs to convert a question in natural language in something that will, in a query, in intended detection, that will allow us to extract data, relevant data, not hallucinated for sure, from the knowledge graph. Imagine that these police officers in the street can ask, using the voice to the system, where this car has been seen in the last few hours, for example. The system will literally provide them the answers without asking them to go through a search interface. The first step is aiming at literally taking all the data and in the graph and extract relevant insights. This process generally is something that we perform as any other data science project. So we start with the definition of a goal, preparation of the data, and then we run several algorithms to extract the data. Here are a few examples in which we extracted from crimes and offenders. We created a co-offender network where two offenders are connected if they committed a crime together, and then we can run some community detection algorithms like Louvain, library propagation, and this is an example of how they will be seen. Then another potential use case is using link prediction facilities to predict links between offenders or between crimes and potential offenders. And again, LLMs was a great help even here, because after you extract all this information, you extract organized crime groups, etc. You needed to organize this information in a way, and LLMs has been proven to create interesting summary that are intelligible also from several type of audience, let's say. And in the end, I'd love to give you a few takeaways from this presentation, because we have seen how the different challenges that law enforcement organizations are facing are related in a way or the other to the way in which the data is managed. And we have seen that these difficulties actually translate in inefficiencies, with the consequences that this can have on people, of course. And the knowledge graphs and LLM have been proven as a valuable solution for that, even though the transition to these new technologies could be overwhelming for many of these organizations. That's why we crafted this three-step process that has been proven to deliver valuable results. And of course, I'd like to remember you about Sarah once more, because it's not about just adopting new technologies, but in this case, is really converting this adoption in people's safety or saving life. And with this sentence, I'd love to thank you for listening to me today, and I'd love to hear your questions.
That was awesome. Thanks so much, Alessandro. Great timing. We have a couple of minutes for questions. Actually, top question right now is from Amy, who just gave our other talk on GraphRag, which is awesome. And she says, in the beginning, you mentioned that dealing with unstructured data, for example, to get it into the knowledge graph, is now oversimplified. Did you mean that there is a negative impact of it being too simple? Or if not, what did you mean by that?
No, I mean, actually, the intent was to say that it's a way more simpler than before, actually. Of course, there is still some need to fine-tuning, but what you get now out of the box is way better than what you got before, after hours and hours spent in annotation, for example. That was super tedious with very poor results that, as you can imagine, can determine that many of these will not end in a good solution in the end, or in an adoption, actually.
Yeah, that makes a lot of sense. I mean, it's certainly, infinitely easier than it used to be. It used to essentially not even really be possible. Out of curiosity, from a tooling perspective, how are you getting unstructured data into, how are you getting your unstructured data into structured data, which you then put into your graph systems? Are you using like a tool? Or are you just leveraging tool calling? Like, how are you doing that?
Well, we have a tool in Neum called Orchestra that is literally an orchestrator tool, where you can define several workflows in which we can take the text from the original sources because we have support for S3 or Azure Blob Stores or even local file systems. And then we can pre-process it, then send it to external microservices that will provide us the LLM's capabilities. And once the data is extracted, we have other components that will literally map the data, after the process from LLM in the graph. We learned a lot how to write the proper prompting in the different LLMs available, including, of course, not only the public available, but also the let's say private one, the open source ones, because of the sensitivity of the data sometimes. And we know how to map the results in the graph. So we consult our customers on this process as well. But we have our own tool that supports, in a production-ready fashion, this entire process, because we can monitor, we can literally, control that every single step is performed as expected. Because, of course, as you can imagine, the quality should be guaranteed at each of these steps, for the consideration that you have at the end of the process, that will come from the graph.
Yeah, and I was going to ask, similar to what I had asked Amy, which was, are you doing a lot of that upfront work to define the ontology of the graph and the things you want to structure, or are you letting the LLM kind of build that graph dynamically? How are you deciding between those two levels of...
Well, that's a very good question, because actually LLMs joined the party quite late. So many of our customers already have their own schema, actually. So changing the schema right now based on unstructured data is a bit more complicated. So what we do is to adjust the existing schema with the new information that we can extract from LLMs. But definitely the ontology is very dynamic in this context, because we are in the process of merging structured data that so far was the most of the sources that we considered, with unstructured data that is relatively new in the process.
That's really interesting. Yeah, that's actually so interesting. It makes me it gives me a follow-up question that you're not going to be able to answer right now, but maybe you and or someone else that's like deep in the graph system community might teach people who are coming from the LLM and ML world who are trying to leverage graphs is like, how do you handle schema evolution, but really like ontology evolution? Like how does that work as you evolve your product or evolve your system and you're bringing in new things? Like I know how that works in structured data, in data warehouses and those kinds of systems. Most people who come from this world have also had to work in that world for a long time, but I actually have no idea like what that looks like in the world of graphs.
Well, definitely, I think that I see personally knowledge graphs as the central part of this system. And in that sense, the knowledge graph should be created independently from what are the different data sources that you are taking into account. The knowledge graphs serve the purpose. So they evolve, as you said, and this is definitely correct. They evolve according to the needs, according to the opportunity to ingest the new data. So definitely the considerations around the data source should be done. If it is structured, you will do some sort of considerations. If it is unstructured, you will do some other sorts of other considerations actually. But doesn't change from my perspective, because your goal is to have this curated knowledge that is your asset. So you can't let LLMs to drive because it is able to extract this rather than that. And many of our customers demonstrated this approach because they are very conservative, let's say, in the structure of the graph, because the structure of the graph represented the way in which they work. So what they try to do is to get the information to match the structure, whatever is the data source. So, and let's say textual data or unstructured data is not an exception.
So I did not pick the speakers that got to come onto my track, but I'm incredibly happy that we have been consistently pushing this theme of like this upfront defining your systems, defining your outputs, defining your ontology, whatever it is. That's awesome. I love that that's happened just by chance. It seems like all the experts have aligned on the same solution to this problem, which is great. Alessandro, do you have any like links or things, QR codes to drop so people can learn more about what you're doing and learn from you? Any
I already shared the presentation, and there you will find other links where you can just get more.